Okay, good day, good people. Let us look at one question here. Um, Let us look at that one question here and work on it a bit. Okay. Let's say we are given. Let's say we are given y equals to x squared and y equals to 2x minus x squared. Okay. They want us to find the area of the region enclosed by the parabols y equals to x squared and y equals to 2x minus y. That's what they want us to do. Now, the first thing that we do is to draw the above graphs. Okay, that is the first thing. Draw the above graphs. That is the first thing that we need to do. Right. Start with this one. We want to say let y equals to 0. If y equals to 0, then our x equals to 0. Let x equals to 0, then our y equals to 0. Then we have 0, 0. Right, then the second one, it is y equals to 2x minus x squared. Let y equals to 0, then we are having 0 equals to 2x minus x squared. Then we will have, then we'll take out the common factor here. The common factor would be x. Then we'll have 2 minus x equals to 0, x equals to 0, or x equals to 2. All right, that's what we have there. Then we can then draw our graph. Now, before we draw our graph, we then have to determine the point of interception. The point of interception in calculating it will say will denote this one as our y1, then this one is our y2. We'll say y1 equals to y2. We'll equate the y's, okay? In equating the y's, we want the point of interception. Now, the point of interception, it will give us the limits that we need to use, okay? Then we are having x squared equals to 2x minus x squared. Then when we transpose this to the other side, we are having x squared plus x squared minus 2x equals to 0. Then we are having 2x squared minus 2x equals to 0. All right, that's what we have there. Then we can take out the common factor. The common factor would be 2x equals to x minus 1 equals to 0. Then our x equals to 0, or our x equals to 1. Then we can then draw the above graph. Okay, we can then draw the above graph. Hopefully I will draw it nicely, but if not, you will get the picture. Oh my goodness, me and drawing, really, me and drawing. Oh my goodness, let's try once more and see if we can't and see if we can't. Okay, let's use yes, much better, much better, much better, much better. Much better. Right. We can then draw our, remember the first one, we are having 0 and 0 on our axis. We are having 0 and 0 on our axis. That would be the first one. Now we will draw that. This is what we have here. Right, this graph, it is y equals to x squared. 0 and 0, that's where our points are. Then the second one would be, our second one, we just determined it, that it has to cut at 0 and 2. 0 and 2. But before that, let's increase there. Let us increase. Let's do this and increase and increase. Okay, oh come on now, I want the thick one. Let us then increase our x here. This is our x, okay? I have a reason why I increase, because I want to write this nicely. Now we are having this here. Let's make it quite thick as well. Okay, this is what we have here. We are having this. Boom. Right. Now this is 0. Then where they intercept, that would be our 1. Okay, that would be 1. Then here it is 2 as determined. This is our graph. Y equals to 2x minus x squared. That's what we have. Now we then have to calculate for this area. This is the area that we need to calculate here. That is the area that we need to calculate. This is the area that we need to calculate here. This is the area that we need to calculate. Now in calculating that area, this is what we need to do in calculating that area. Let's make it quite thick as well. Right, in calculating the area, we then have to get the difference between the two curves. Let's come on the second page. We then have to calculate the difference on the two squares. In calculating the difference on the two squares, we will say y2 minus y1. That is the second thing that we need to do. Get what? The difference between the two curves. Difference. Let's write it. Difference between the two curves. That's what we need to do. Okay. Now we are having y2. Our y2, we did say that it is 2x minus x squared. It will be minus x squared. All right. Then in adding the like terms, we are having 2x minus 2x squared. Right. We've managed then to determine the difference between the two curves. The region between, this is the region between the curves. Region between the curves. Region between, come on now, the curve. That's what we have. Okay. Now we will then integrate. It will be area equals to the limits. I said it, we did determine our limits. In determining our limits, we had to say y1 equals to y2. Then we got our limits as 0 and 1. Then we are having the difference of difference between the two curves. It is 2x minus 2x squared dx. We can then integrate. Now in integrating the above, then we will have 2x squared minus divide by 2 minus, we are having 2x 3 divide by 3. Right, then our limits would be 1 and 0 plus c there. Okay, and then in simplifying it further, we will have 2 and 2 will cancel out. We'll have x squared minus 2 divided by x to the power cube. Then from here we can then calculate our area. Then from there we can calculate our area. And in calculating our area, we'll then substitute. Let's come here. We'll then have to substitute our x with 1. Then we are having 1 to the power squared minus 2 divided by 3 multiplied by 1 cube. All right, open close bracket minus, then where there's x we put 0, then it will give us what? 0. All right, then we can then calculate. We are having 1 minus 2 over 3, then it will be 3. How many times does 3 go into 1? 3 multiplied by 1, it will be 3. How many times does 1 time? Then 1 multiplied by, it will be 2. Then we get our answer as 1 over 3 unit squared. Boom. We've then calculated our area. After we've calculated our area, we can then get the strip in this, can then get the strip. Now, in getting the strip, we will be moving from the low to the high. Okay, low to the high. Now, we will be moving from the low to the high. Now, this would be where our strip is here. Which one it is the smallest or the lowest? It is this one, y1. The highest it is this one, y2. Low, high. This is where our strip would be. Boom. That's all you do here. That's all you do. From low to high. From low to high. From low to high. From low to high. Right? That's all you do. This one it is the low, 0 0. This one it is 0 1. From low to high. This is how you tackle such questions, whereby you need to determine the area between the curves. Determine the area between the curves. This is the area between this is the strip that we determine it within this area. This is how you do it, good people. Thank you, good people. We'll post another one now.